welcome. In section 8.3, we get to play around with trig integrals. A couple tools that we'll need. Sine squared theta plus cosine squared theta is 1. That's one that is handy, comes in quite a bit. Power reducing formula, sine squared theta 1 minus cosine of 2 theta. This is not cosine squared, but cosine of 2 theta all over 2. And cosine squared of theta turns into 1 plus cosine of 2 theta over 2. So sine turns into a minus, cosine turns into a plus. So those are just a few of the tools that we'll need later on. So we'll start with doing just an indefinite integral of cosine to the 4th x sine to the 5th x times, of course, dx. So the sort of odd power out, the one with the little extra, was the sine. So we'll make this cosine to the 4th x sine to the 4th x times sine x dx. Now the idea here is this part we want to eventually look like a du. These sort of leftover parts. So since this is a sine x dx, we're going to try to turn things into cosines then. So I'll hang on to this cosine to the 4th x for the moment. And sine to the 4th x, sine squared x times sine x dx. And sine squared, of course, then is 1 minus cosine squared. Times sine x dx. So each of these just got swapped out for a 1 minus cosine squared. We can go ahead and multiply out. So we have integral of cosine to the 4th x times 1 minus 2 cosine squared x plus cosine to the 4th x times sine x dx. Now, because the derivative of cosine is negative sine, not just sine, we're going to want to do a little manipulation here. So let me go ahead and distribute this guy, and we'll also break him up a little bit into pieces. So our first integral, cosine to the 4th x, leave a little room here, sine x dx. So distributing these guys in, again, because I want a minus sine x to be involved there, multiply inside and outside by a -1. That way we've multiplied by something worth a positive 1. We changed the look, but we didn't change the value. Distributing these to the middle guy, then we have plus integral of -2 cosine to the 6x sine x dx. So we already have our minus there. No problem there. And finally distributing it to the last one. So plus integral of cosine to the 8th x sine x dx. We don't have the negative that we want, so we'll multiply inside and outside by a -1. So then we'll make our u equal cosine x. du would be then the minus sine x dx that we were after. So what we have then, minus integral of u to the 4th du plus 2 integral u to the 6th du and minus integral u to the 8th du. So after that, now it's just a plain power rule problem. So negative 1/5 u to the 5th plus 2/7 u to the 7th minus 1/9 u to the 9th plus an arbitrary constant. And then we just plug our original guy back in. U was cosine x. So we have minus 1/5 cosine to the 5th x plus 2/7 cosine to the 7th x minus 1/9 cosine to the 9th x plus an arbitrary constant. So that's the idea, is just use these identities to turn it into something simpler until we're eventually working with just a simple u substitution. Okay, so our next one, we'll do our integral of cosine cubed of x over cube root of, so that's an index of 3 down there. I know those can be hard to read. Cube root of sine x times, of course, dx. So this one, I notice I have an odd number of cosines here. So I'll make that sort of the odd man out. I'm also going to get this guy out of the radical and out of the denominator. So we'll do integral of sine to the negative 1/3 x cosine squared x cosine x dx. So the cosine x dx, we're looking to eventually make that one our du. So we're looking to make everything into sines this time. So cosine squared is 1 minus sine squared, of course. So we'll go with that. And we'll hang on to the cosine x dx. A little bit of distributing and we'll split them up. So you have the integral of sine to the negative 1/3 x cosine x dx minus integral of sine 2 is same as 6/3, so sine to the 5/3 x cosine x dx. So u is sine x, making du cosine x dx. So we have integral of u to the negative 1/3 times du minus integral of u to the 5/3. Well, that is a messy 5/3. U to the 5/3 times du. So u to the negative 1/3, add 1 in the form of 3/3, and we're at u to the positive 2/3, so we'll need a 3/2 out front there. U to the 5/3, add 1 in the form of 3/3, so u to the 8/3, so we'll need a 3/8 there. And hang on to that minus sign in the middle. And then we just put our original variable back in. So 3/2 sine to the 2/3 power of x minus 3/8 sine to the 8/3 of x plus an arbitrary constant on the last two steps. Okay. So that got us playing with sines and cosines. This next problem we look at what happens if we didn't start with both sines and cosines in one. So we'll do integral of sine to the 4th of x dx. We can, of course, break it into a couple of sine squareds. So sine squared x times dx. And we can use our power reducing formula on that. So here we'll use the fact that sine squared theta is the 1 minus cosine of 2 theta over 2. So the integral of 1 minus cosine 2 theta over 2, 1 minus cosine 2 theta over 2 times, my apologies, those are not thetas, those should be x's at the moment. My apologies. X's there. So we can go ahead and FOIL that out a little bit. So a half times a half is a fourth. We have minus a fourth of cosine 2x minus another fourth of cosine 2x plus a fourth cosine squared of 2x. All of that times dx. We can use the power reducing again on this cosine squared. So recall, cosine squared theta is 1 plus cosine 2 theta over 2. So the integral of a fourth minus a half cosine of 2x. So we just put those other two guys together there. And then I'm going to go ahead and apply that to this last term. So I'll hang on to this 1/4. And then we have half plus cosine of 2x over 2. So here our theta is 2x. All of that times, of course, our friend dx. So we have the integral of a fourth minus half cosine 2x plus an eighth of cosine of 2x. All of that times dx. And then we have a couple of like terms that we can handle there. So we have a fourth plus an eighth, so that's 2/8 plus 1/8 is 3/8. Half cosine 2x, eighth cosine of 2x, so that's minus 4/8 plus 1/8, so minus 3/8 of these cosine 2x's times our friend dx. So the first one, just our power rule, so that's 3/8 x. Hang on to minus 3/8 and do the antiderivative of cosine of 2x. So sine of 2x times 1/2. So to avoid having the 2 there that we would have with the chain rule. And since we did our antiderivative, plus c, so then just a little cleanup at the end. So 3/8 x minus 3/16 sine of 2x, close it up, plus c. And there's our antiderivative. All right. So next up, we'll play with secants and tangents.